Fearless is an exception. Now you're soluble. Right? It's just like saying everybody has to take next week except Gary. Gary's an exception. He doesn't have to take the test. To everybody else, the rule applies. Or nobody has to take the test next week except for Race. Right? So now nobody has to take it, but Race is an exception. He has to take it. Okay? So do we kind of get that? And we'll look at some of those in a minute. Okay? So some of this might be a little repetitive of what we said the other day, but we're still going to go through this. Okay? So we'll say predicting the products of a double replacement reaction. So let's say we're given AB aqueous, because it's in solution, plus CD aqueous to yield. Well, let's think about what that means then. If these things are aqueous, it means they're dissolved, right? And it means then that they're floating around in solution with a bubble of water around them, a hydration sphere. So A and B are floating around separately, actually, in solution. They're actually separate from each other. And in another container, I got C and D floating around. It's almost like couples dancing. Like imagine you go to a wedding, and you're dancing with your grandma, and your mom's dancing, or your brother's dancing with your mom. And then you switch partners, right? You're not going to be dancing with your brother. You're going to be dancing with the other female, right? And it's the same thing with atoms here. When they switch places, it's only the positives switching places with each other, or the negatives switching places with each other, because they got to get positive and negative. Right? So our new combinations are A with D and C with B. And notice I'm putting C first because C comes first in its compound, B comes second in its compound. So basically C is a cation, B is an anion. There's a couple ways to look at this. One way is, you guys all know how to FOIL, right? Remember the FOIL method? What's the FOIL method? First, outer, inner, last. But here in chemistry, you just go, oi. So what are you doing? Outer, inner. So if we look up here, let me find my pointer. If we look up here, A and D were the outers, A and D. And C and B were the inners, B and C. You can't do the first because that would take a cation and put it with a cation. They're not going to bond anyhow. Positive and positive is not going to bond. And last, B and B, they're not going to because they're both anions.
Does it matter if A or D or C or B goes first?
It matters if A goes before D. It does not matter if you put down CB first, then AD. Like if you want outers, inners, or you want inners, outers, that wouldn't matter. But the cation, the first thing should be first.
It's kind of off topic, but can you mix two liquids and then the yield is a solid?
That's what we're going to get.
Oh, that's what we're doing right now.
Mm-hmm.
Oh.
Exactly. Okay. So, essentially what we're getting is AB aqueous plus CD aqueous. Basically, these guys here, A and C, trade places. That's another way to look at it. This is like you changing partners in the dance. It's like oi, right? We're not saying A is going to end up with C. We're saying they're swap places. So if we swap places and we put C next to B and A next to D. And so we get the AD, AQ. Or I should say, let's not put a state here. I'm just going to put AD plus BC or CD. I had that right the first time. CD, and I'm going to put the parentheses, but I'm not putting any state in right now.
So you use E twice?
No, CB. Thank you. Keep me honest, Ethan. Okay, now, the way you get these guys is you crisscross. You get these. And this is most likely to be the biggest mistake that people make in this whole long process. And it's a fairly long process, and you'll see at first it'll look intimidating, but I'll tell you what, my academics took a test on it yesterday, same basic test that you're going to take, and there were guys that aced it. All right, so just when you start this out, it'll look intimidating, but don't fret, okay? It's not as bad as it looks. And then when we go tomorrow to do the next type of reaction, it's going to be very similar. And on Friday when we do the last type of reaction, it's going to be very similar. So it's going to be the same thing over and over for five class periods in a row. I think you guys are bright enough to get this. Okay? And I say that sarcastically because I know. Right, so, and then the states, we're going to use the solubility rules. Determine the states using solubility rules. Okay, now again, yes.
That says states, right?
States, yes. Yeah, believe it or not, it does say states.
Sorry.
No, no, it didn't. When I looked at it again, it didn't. Determine the states using solubility rules. Okay, so if a solid precipitate forms, well, let's do it this way. If a solid precipitate does not form, then there's no reaction. Right, no reaction. So you're gonna like that problem on the test. I'll tell you, when you get to your test on next Wednesday, there's gonna be 5 problems on that test. Okay? 2 of them are going to be the type that we're talking about today. 1 is going to be you have a lot of work to do. 1, all you're going to have to write is no reaction. Okay? And then later on, you're going to find out there's going to be another no reaction. So on this next test where there's 5 problems, 2 of them you're going to get 15 points each by saying no reaction. So this one, you just have to know how to interpret your solubility rules. So if I would look at the new combinations AD and CB, whatever they are, we'll do an example here in a second, and they both came up aqueous, all right, no reaction. If one comes up insoluble, that means you have a precipitate solid, there's more work to do. I would not give you 2 things being a precipitate. It's only going to be 1. All right. All right. If a solid precipitate does form, then you need to write the following 3 reactions. Or I should say equations, following 3 equations. Here we go. Now we're going to get down to the business. Get down to brass tacks. That's what my old neighbor used to say. He passed away some years ago. But my old neighbor used to always say that. Get down to brass tacks. It's like when you get down to the nitty gritty. Okay. All right, let's say, and this is actually going to describe the solution of, the reaction of taking those 2 clear solutions and getting the yellow stuff like you did earlier this year. Okay, so this is the reaction we're talking about. So our first reaction is called a formula or molecular equation. And essentially, that's just a balanced chemical equation. Just a balanced chemical equation. So let's say we're given PB, parentheses, NO3, parentheses, 2, AQ, and NAI, AQ. Given. So let's say I tell you, okay, you have these two solutions. If you mix them together, what, if anything, happens? And so first thing you should do is first determine if a reaction occurs using solubility rules. Definitely do that first, all right? Because you're going to see, you can't see what I got in front of me, but if I have to write all these equations, then I got a lot of work. Remember, we said, again, determine if the reaction occurs, so that means if there's a precipitate or not. So I already said that up here. If a precipitate does not form, then there is no reaction. But I'm trying to remind you again, because this is a common mistake, that I want to see what happens, okay? So I'm going to go look up first, and I'm going to lead you down the path the wrong way. Let's say I say Na with NO3. Okay, and I look at NO3, and NO3 says, all cations form soluble. So right now I'm assuming it's aqueous. I'm looking to see if sodium is an exception. And I read through it, it says the exceptions are KClO4 and AgC2H3O2. No mention of sodium. It follows the rule, it's aqueous. So as of right now, I don't know if I have a reaction or not. Then I'm going to go look at the rule for PB getting together with I. And I read the rule for I, and it says all cations form soluble. So right now I'm thinking soluble, I might be off the hook. I might get both soluble and be able to say no reaction. Joe, you with me? Just checking. All right. So PB with I, the rule goes, all cations form soluble except silver, mercury, and lead. It mentions lead as an exception. So that means it's a solid. It means there's a precipitate. It means we got work to do. We got to write the reactions, okay? I didn't want to pick on you. I just wanted to make sure you were there.
Yeah.
All right, so I got my PB, NO3, parentheses, 2, aqueous, plus my NAI, aqueous. Now, how do I figure out what my products are? A process that you should know how to do already? Okay, you're going to do OI and
Dissociation reaction.
we're getting there. How do we get A and B and B and C? You got to crisscross, okay? Don't take shortcuts here. Don't take shortcuts. You need to write down your charges because you're going to need them again later. And I see guys that take the shortcut and the guys that try and take a shortcut and it never works, right? So PB is getting together with I, and NA is getting together with NO3. So notice I'm writing them up above. And I'm just going to go backwards because the lead's the one that's the issue. NO3 on my polyatomic ion sheet is negative. Sodium is a positive because it's group 1. Iodine's in group 17, so that's a negative 1. All right. Now, PB, if I go to my periodic table,